The time taken to travel to college by 2,500 students are summarized in the table. Draw a histogram to represent this information. Okay, so we have to draw a histogram. So to draw the histogram, if you see here the width is 20, here it's 10, here it's 10, here it's 20, and here it's 30. So what we do first, we will find the frequency density. Okay, so for frequency density, if we see class width, so class width over here is 20. First class width is 20. Second is 10. Third is 10. Fourth is 20. And fifth one is 30. Now density, if you find, so it is 440 divided by 20. So here density, frequency density, if you see frequency density, so here 440 divided by 20 is what? It's 22. 720 divided by 10 is 72. 920 divided by 10 is 92. 300 divided by 20 is 15. And 120 divided by 30 is 4. 120 divided by 30, yeah, perfect, is 4. So here in this diagram, we will start with 0. So here the initial point is 0. So this is 0. Then this is 20, 40, 60, 80, 100. If you see, it is up to 90. Okay. Now frequency density, the maximum density is 92. So along this, we can divide this as, we can start with 10. So we say this is 10, 20, 30. Let me reduce this little bit so that we can see all. Shall I reduce it further? Okay. Yeah. So this information which is here, so 10, 20, 30, 40, 50, 60. Okay. So that means we should label it as, instead of 10, we can start with 20. We can say that this is 20, this is 40, this is 60, this is 80, and this is 100. Okay. Now 0 to 20. 0 to 20 we have frequency density 22. So this is 20 and this is 30. So 22 is somewhere here. So I will draw one box like this. Then 20 to 30 we have density as 72. So 20 to 30. So 30 is here, this line. And it's a 72. 72 is, this is 70. and 72. So this part. So we join like this. So this is 20 to 30. Then 30 to 40 we have 92. So 30 to 40 we have 92, 80, 90, 92. It will be like this. Okay. So you are using scale. With scale you can draw perfect lines. Here it is difficult for me, but you can do. So you understand how we can draw this, what we call histogram. Okay. So I will move to the next part because this you can do. Now next part of the question here is from the data, the estimate of mean value is 31.44. So mean is given 31.44. Calculate the estimate for standard deviation of the time taken to travel the college. We have to calculate estimate for standard deviation. Now for that I need class mark first. So here midpoints we can say. So I will make column once again in which we have midpoint and we have their respective frequency. So midpoint, the first midpoint is 10, then 25, then 35, then 50, and then 75. Okay, you can see here. So 10, 25, 35, 50, and 75, and their frequencies are 440, 720. So here the frequencies are 440, 720, then 920, 920, and 920, 300, and 120. So 300 and 120. So to find standard deviation, we will first calculate variance. So your variance is going to be, variance is equals to, here it's 10 square times 440 plus 25 square times 720 plus 35 square times 920 plus 50 square times 300 plus 75 square times 120. Okay, this divide by the total frequency is 2500. You can check again, it's 2500. Okay, minus mean is 31.44. So this minus 31.44 square. Okay, so we calculate this part and the calculation will result in answer as it will be 304,600 divided by 2500 minus 31.44 the whole square. So result will be 229.9264. this is your variance. Okay, what is the standard deviation? The standard deviation is square root of this variance. So we will take square root of this, and it is 15.2. So 15.2 is your variance. Now, in which class interval does the upper quartile lies? So upper quartile, in which interval this upper quartile lies? So for that, we will find the cumulative frequency here. These frequencies we add, so this is 440. I am doing here only 440 plus 720. So 440 plus 720, it gives 1160 plus 920, it is 2080 plus 300, it is 2380, and last it is 2500. Okay, so upper quartile, that means 3 divided by 4 times 2500, 1875. So 1875, it is here 1875. Okay, so 30 to 40. So here the question is, in which class interval does the upper quartile lies? So it lies in the class interval of 30 to 40. Now, if it was later discovered that the time taken to travel to the college by two students were incorrectly recorded. One student time was recorded 15 instead of 5, and the other, it was recorded 65 instead of 75. So instead of 5, if I record 15, it will not make any difference. Okay. Now instead of 65, if I record 75, that also does not make any difference, because they are in the same range. Like in 0 to 20 we have, okay, that 5 and 15, and in 60 to 90 we have that 65 and 75. So there will not be any impact on the result. So here, without doing any further calculation, state the reason whether the estimate for standard deviation in part B would be increase, decrease, or stay same. So here we can say that it stays same because data is in the same interval. It stays same. Why? Data in same interval. So as the data is in the same interval, we can say that there is no impact on the result.